measurement of the side x. So when I have a question like this, the first thing I will think if I can use any of the ratios that the trig ratios. We can only use the trig ratios if it's a right triangle now. So this is a right triangle, yes. I know an angle other than the 90-degree angle. What I'm missing, what is this side represents for this angle? Is it hypotenuse? Is it opposite? Is it adjacent? It is opposite, and this side, which is next but not the hypotenuse, is the adjacent. So we know the angle, we know the opposite, we want to find the opposite, and we know the adjacent. So if we can use tan, so we say tan of this angle equal the opposite side, which is what I want to find, x, over adjacent, which is 9.2. Now I can use my calculator and calculate what is tan 28. I told you yesterday, make sure that your calculator is in degree mode, or otherwise all the answers will be wrong. So tan 28. Okay, we usually try to write it up to 4 decimals. So 0.5317 equal x over 9.2. How we solve this equation? We multiply both sides by 9.2. So x will equal this times 9.2, and that will be 4.8917. So we can write it like this, approximately. Alright, so this is how we do this kind of questions. We set up the ratio and we solve for the missing side. Okay, now let us have another example. Example 2. It says a radio transmitter is to be supported with a guy wire as shown. The wire is to form 65-degree angle with the ground and reaches 30 meters up the transmitter. The wire can be ordered in whole number length of meter. How much wire should be ordered? So we have a radio transmitter that is supported with a guy wire. This wire reaches up to 30 meters tall, and this angle is 65 degree, and this is a right triangle. We need to find the length of the guy wire. For this triangle, I know that this is a right triangle, so I can use the tan. This is 65 degree. I know the opposite, and I want to know the hypotenuse. We don't know yet the ratio that works with the opposite and the hypotenuse. We're going to learn it tomorrow. This is called sine, but for now, we are going to use what we know. So I cannot find the length of this guy wire directly, but if I find the length of this side, I can use Pythagorean theorem and find this one, because this will be the hypotenuse. So I will use tan 65 equal the opposite, which is 30, over the adjacent, which is what I want to find now. Let's say it's x. Now I want to isolate for x, so I will multiply both sides by x. So x tan 65 equal 30. I will divide both sides by 1065, so x can be free. So 30 divided by 1065. Now I isolated x. Again, 1065 equal opposite over adjacent. I want to solve for x. I multiplied both sides by x. Actually, what we did is we exchanged the x and the 1065. But I want to show you where it came from. X 1065, then divide by 1065. You will find x right away. So I will put here in the calculator 30 divided by 1065, close bracket, hit enter. The length of this side will be 13.989, so let's say 13.99. Okay, now I can find the length of the wire because, so the guy wire squared will equal 30 squared plus 13.99. So guy wire will equal the square root of what we get from here. So this will be, this is squared because of Pythagorean theorem, and this is the hypotenuse. So this to the power of 2 plus 30 squared, 900, square root of that. .09, we can say it's almost 33. Alright, so this is example 2. I will do another example. Alright. So this example says we have a triangle like this. This angle is 48 degrees. This angle is 35 degrees. This is the height. And this is 10 meter. And we need to find the area of this triangle. So in order to find the area of this triangle, we need the length, the base, and the height. Because area equal 1/2 base times height. So from this triangle, if we say this is x and this is y, I can find the height because it's in a right triangle and it's opposite, and I know the adjacent, so I can say 1035 equal x over 10. So x equal 10, 1035. I just multiplied the 10 in here, and that will be x. So 10 times 10, 1035. Close the bracket, hit enter. So the length of this x is almost 7.002, so we can say it's 7. So this is 7 centimeter. Now, if we look at this, we need y as well, so we can get the base. If we look at this right triangle, we have 48 degrees, and I have y, and I know that this is 7. showed you yesterday that we exchanged the positions. So y will be here and tan 48 will be here. So y will equal 7 over tan 48 because I multiplied, let's do it, y tan, I multiply both sides by y tan. So then I divided by tan 48, so this is what we have. So 7 divided by tan 48, this will be 6.3. So this part is 6.3. Now I can tell that the area will be 1/2 the base, which is from here to here, so 16.3 times the height, which is 7. Okay, so 16.3 times 7 divided by 2 or multiplied by 1/2. So the area will be 57.1 unit or centimeter squared, if it's centimeter, unit squared. Okay, this is how we use tan to solve